All right. Welcome to my Thursday. My Thursday is the day. We should have a level on our Patreon or something that's like, buy me a new set of dry erase markers. Oh boy. All right, welcome to my Thursday, everybody. I'm just grabbing my markers. All right, if you have anything that you are working on in math, if you have any questions or anything like that, you can pop them in the chat. So we are here. We're gonna do, this is just kind of live math teacher help. So anything you are struggling with, anything you have questions about, maybe it's something that you just never really got in math class, you never really understood it. So we primarily focus between like pre-calc and, or pre-calc to some extent, but mainly pre-algebra through like pre-calculus or algebra 2. So if you have any questions or anything, put them in the chat. Even if you have a question that's on like calculus or more advanced topics, I may not be able to help you out, but there's a lot of people in the chat who would be more than happy to help you out. So it's a great little community we have going on here. So let's start out by let's just start with just like some simplifying. Let's just do some simplifying of a function. Let's do simplifying of an expression. Okay. Triangles in circles. Do you mean, tell me a little bit more about what you mean, 4K Blitz with the triangles and circles. Can you give me, maybe list some like vocab words or something like that that you've got that you're working with? Just to give me a little bit better idea of where you are. Okay, so chords and tangents. Oh, thanks. I tried. Secant lines, segments. Okay, all right, great. And you're just in a regular geometry class? Okay. So when you're doing these, trying to get, that's okay, Devilman, you are right on time. Okay. All right, so 4K Blitz, let's get into that. I'm just gonna simplify this first and then let's get into it. Okay, so 2 times 4x plus 2, so we're gonna distribute this. Distribute this 2. So it's 2, we're gonna distribute by multiplying everything by 2. So this becomes 8x plus 2. Now we haven't done anything over here, so this is actually gonna stay as minus 5x plus 3. So now with this, with simplifying, remember, we're not solving it, right? We're just simplifying it. So now we've got 8x plus 2 minus 5x plus 3. So we want to combine and put together things that actually go together. So for example, we've got 8x Then we've got minus 5x. So if we put these together, what happens is you're going to take away 5 x's because they're negative, and you're going to be left with 3 x's. So 8 minus 5 is 3. So we've got 3x, and then we have 2 plus 3, which is 5. So this all simplified down gets down to be 3x plus 5. Okay? So we've got 3x plus 5, because we didn't do anything to this negative 5x. That's just going to kind of keep dropping down. Okay? Okay, so we're just looking for these like terms. So we're combining the 8x and the minus 5x and then the 2 and the 3. So we can also think about this if we kind of rearrange it a little bit. So this 2 went to that 5 when you, well, sorry, this 2 went when you multiply, what am I saying? This 2 was added to this 3 to give you this 5. Now, if you're talking about this 2, that I multiplied through. I did 2 times 4x, 2 times 1. So that's where I got that 8x plus 2. But then what I did was to get 3x, I took that 8x minus 5x, and then I do 2 plus 3, which is 5. Okay, so yeah, exactly. So this is just adding the like terms. You're just kind of putting everything together that matches up and that's going together with that. Okay. All right, so we had a question before about tangents and secants, and we'll just kind of talk about that. We'll start with just the vocabulary, I think. I think that's probably important to first sort of go over those things, right? Okay, so let's talk a little bit about circles. Right. So Mark, I'm teaching basically anything from pre-algebra through like beginning pre-calculus. So algebra 2, trig, there's some things in pre-calc that we can get into, but a lot of the pre-calc and calc stuff, it just kind of gets really dense really fast, and it's hard to like kind of convey in this sort of environment. But if you have a more advanced class, or if you have a more advanced question, put it in the chat and there may be somebody who can help you out with it. Okay. All right. So we're getting a lot of standard forms, factored form, quadratic equations. So we will definitely do quadratic equations. Okay. So with these, so when we're talking about circles, okay, if we've got a circle and there's our center, okay, so the distance all the way around the circle is the circumference, okay? So that's the circumference. Now the distance from the center to one of the sides is the radius, okay? So that's the radius. And then all the way across through the center to 2 points on either side, that is the diameter, right? Now there's a lot of other things that we can do within a circle. So we have the center, we have the diameter, okay? We have, if we have a line segment that just connects 2 points on the circle that does not pass through the center, that is a chord. C-H-O-R-D. Okay. Now, if it cuts through the circle in 2 spots and it keeps going, okay, I think it can go on forever. Yeah, it can have arrows on the ends. Yeah. That is called a secant. Okay, so that is a secant. And then the last bit of, kind of the last little thing would be a line that just intersects the circle at one spot on the side. And that is called a tangent. Okay, So the distance from the center to the point of the tangent where it intersects, that's always going to be the radius, right? The distance from the center to any of these points on the outside or on the circle is going to be the radius. That is what makes a circle, is that from the center point, it's all the points that are the same distance from the center. Okay, so that's why you're able to use a compass, not just for drawing circles, but for marking all the points that are the same distance from one other point, if you're using a compass to draw those curved lines. Excuse me. So with these, okay, there's a lot of different things when you're talking about the intersecting like secants, intersecting secants, intersecting tangents, chords, radius, all of that kind of stuff. So when you're going through these, different vocabulary words, there are lots of formulas that go along with it, like those triangles. And honestly, the best thing to do is to just practice, practice, practice. Once you understand these vocab words, and when you start talking about an arc length, right? So an arc is this curved part here. That's like the arc length. It would be sort of like that portion of the circumference that's being measured, okay? And what's interesting is that's sort of where the thing about radians, I think that's where you can, that's where the radians come from, is a specific arc length. When you have an arc length that's equal to the radius, that's 1 radian, basically. It's pretty cool. So with these, you can kind of do different triangles and things like that. And there's lots of different formulas that go into that. So I hope that was helpful. But okay, so let's get into quadratics. Oh, there's something drawn in the back. What was that? Oh, that is from factoring before. Okay. All right, that was from last week. All right. Simple interest. So I'll add that to the list. We'll get to simple interest after quadratic equations, okay? All right, so quadratic equations. So solving a quadratic equation, okay? Solving a quadratic equation there's a few different ways to do this. So one way is to do factoring. If you can factor it, great. The other way to solve, or one of the other ways to solve quadratic equations, is completing the square, which is also fun. And then the third way that works for any quadratic is the quadratic formula. So we will focus on, let's just talk about first just factoring. Then we'll talk about the quadratic formula, and then we'll look at what it looks like on a graph, okay? Hey, Pancake Mix, welcome. Okay, so let's do solving a quadratic. Let's do it just by factoring first. Yeah, let's see if we can factor it first. So let's start out with, we've got x squared plus 6x equals -8. Okay, so the first rule of solving a quadratic equation when it's something along these lines is you want to make it equal to 0. Okay. Oh, good. There are so many people that have tests on this. I feel like everybody always has a test on this. Okay, so x squared plus 6x, in order to solve this, I need to make it equal to 0. Okay, so I'm going to add 8 to both sides. So that doesn't combine with anything, but it cancels this out. Now, it doesn't just disappear, right? It becomes x squared plus 6x plus 8 equals 0. Okay, now the reason I want it to be equal to 0 is because I'm going to, after I factor it, I'm going to use something called the zero product property, which is where if you have two things that you're multiplying together and you multiply two things together and they equal 0, one of them has to be 0, right? Because anything times 0 equals 0. So if I can get this to be multiplying two things together that equal 0, then I know that in order for it to equal 0, one of those has to equal 0, right? Okay, so I'm going to look at these, and what I'm looking for is two numbers that multiply to 8 and add to 6. Now, if there were a number in front of this x squared, I would actually multiply that times that. Like if this were a 2, I'd be doing 2 times 8. Then I'd be looking at 16 or something like that. That's usually what I do, which is called the AC method. But when we're looking at 8, we want to think about our factors, right? So we have 1 and 8. We have 2 and 4, and that's it. And 2 plus 4 does give me 6. Okay, so I'm looking for two positive numbers that are multiplying to 8 and adding to 6. Okay, this is positive, which means the signs are the same. And this means that they're both positive. Okay, so 2 and 4, that's going to give me my two binomials. So I figure out, I use my 2 and my 4. Those go in here as kind of fill in the blank. And it really is that simple, okay? So when that first number, or that first number that's in front of the x is a 1, it's really that simple. You find what multiplies to that and adds to that, and those become your binomials, okay? So remember what I said about if I want this times this to equal 0, one of these has to be 0, right? So now I split these and I say, okay, well, it's either that x plus 2 equals 0 or x plus 4 equals 0. If one of these two binomials equals 0, then a whole thing is going to equal 0. Okay, so I'm going to subtract 2. Subtract 4, subtract 2, subtract 4. So I get that, I want to add another sheet, but that's okay. So what's going to happen is this cancels out. 0 minus 2 becomes negative 2. And then all I'm left with over here is an x. Or cancels out, negative 4. X equals negative 4. So if either one of these two things are true, if x is negative 2 or if x is negative 4, this is going to equal 0. Okay. All right, so that is if it's factorable. Okay, if it's not factorable, that's okay. Okay. Okay, so let's see, quadratic. Whoops.
We have a question from Instagram saying, can you explain the tan chord?
The tan chord of a circle?
I did not elaborate further.
Okay. Okay. All right, so let's look at another one. Okay, we're going to look at one that's not factorable. Okay. I got to find one that's not factorable. Let's do let's do x squared minus 4x plus 13, yeah, equals 0. Okay. So right here, 13 is a prime number. It's only got 13 and 1. There's nothing that I can do to make 13 and 1. There's no playing around with the signs or anything that I can do to make it add to -4. So I look at this and I go, it's not factorable. Now, you could complete the square on this one, but we're going to hold off on that. So we're just going to do quadratic formula, okay? So the quadratic formula will always work with a quadratic equation, even if it is factorable. You can just always decide to do quadratic formula. But it's not going to be very fun. It's not always the easiest way. Like that last one that we did, right? We see that it's like, oh, it's 4 and 2. There's my solutions, -2, -4, right? Sometimes factoring is the fastest way to do it. But again, if it's not factorable, we can't do it. Okay? So we are going to use the quadratic formula. So sing it with me, right? We've got x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this a, b, and c refers to the coefficients here. So my a value is 1, my b value is -4, and my c value is 13. Okay, these are probably going to give us some kind of ugly numbers. Oh well, that's what we're here for, right? Okay. So now we just plug in our coefficients, okay? So this one, you can't just factor it. You can't factor it. It's not factorable, okay? So we've got -b, which would be -4. So that's 4 plus or minus the square root of -4 squared. Make sure you put that in parentheses so you don't forget to square the negative. Minus 4 times 1 times -13 all over 2a, which is just 2. Because it's 2 times 1, which is 2. Oh my gosh, I did a terrible job of erasing these boards.
Your words, your words.
Okay. All right, so now let's start to simplify. So I've got 4 plus or minus the square root of 16, and then 4 times 13 is 52. So it's going to be plus 52 over 2. Actually, this is actually going to be not too bad at all. Okay, I'm going to add 16 plus 52 under that radical sign. Ooh, because we're going to get to simplify this radical. That is so exciting. Okay, so we have 4 plus or minus square root of 68 over 2. Now 68 is simplifiable, or square root of 68 is simplifiable, right? So I'm going to look at this root 68. So 68, I'm going to see, I know it's divisible by 4. I'm going to see if it's divisible by 16, because that's a bigger square. No, it's not divisible by 16, but it is divisible by 4. So 68 divided by 4 is 17. Okay, so 17 is prime. So the way that I would simplify this is I know that 68, I'm going to write it like this. 4 plus or minus, well, actually, you know what? I'm going to do a little sidebar. Okay, so let's do a little sidebar about simplifying just this radical. So square root of 68, I just looked at it and it's divisible by 4. Okay, so 68 is 4 times 17. So what I'm going to do is I'm going to think about this as square root of 4 times 17. Now I can take the square root of 4, right? That's 2. But I can't take the square root of 17, so that stays under the radical. So the square root of 4 is 2. Square root of 17 is still just square root of 17. Okay? So what this actually becomes is it's going to become 4 plus or minus 2 root 17 over 2. Okay. So with this 4, 2, and 2, those are all divisible by 2. So I would simplify this just like I would a fraction. Okay, so I've got 4 plus or minus 2 over 2. So 4 divided by 2 is 2. I'm going to write it. Yeah, I'm going to write it down here. So I've got 2 plus or minus, that 2 and that 2 cancel out, right? Like 2 divided by 2 is 1. So plus or minus root 17. And that would be my solution. Okay, so it's 2 plus root 17 and it's 2 minus root 17. Okay, so those are my 2 solutions. Okay. All right. So let's see. Okay, I see systems of equations.
Olivia has been waiting patiently
for simple interest. Yes, Olivia, I'm going to get you with simple interest. Okay, and then we'll do systems of equations. Okay, so simple interest. So simple interest is just based on a formula. Olivia, what grade are you in? What math are you in? Seventh, perfect. Okay. All right, so simple interest. I always learned it. I always learned the formula or could remember the formula by calling it IPERT. I don't know. Anybody else out there? Like IPERT? That's just what I was always told. I don't know. So IPERT is where you have I, which is interest, equals P times R times T. Okay. So we've got the I is the interest, so that's going to be the amount of interest. Okay. P is your principal, so that's what you're starting with. That's your starting amount. Okay. So your principal. R is your rate, and that's going to be as a decimal. It's usually a percentage as a decimal. Okay. And then T is the amount of time. Okay, so we've got interest equals the principal, which is your lump of money, right, or how much money you have, times the rate times the amount of time. Because what interest really is it's just taking a percentage of your money, right, every year, every 6 months, however long it's like is that rate of time, right? That's however long or what kind of rate you have, right? So it might be monthly interest, it might be yearly interest, whatever it is, okay? So this is how you are going to get this. Now, this is just simple interest, so it's always going to be going back to your principal, whatever you started with, right? Good, Olivia. So whatever we start with, we're gonna multiply it by the rate because that's the percentage you're going to get every time it's taking that interest, right? Every time that time period comes around, okay? So if we start with, I don't want to start with one that doesn't have the rate. Okay, so let's say I'm going to deposit $5,000. Okay. I wish, right? So I'm going to deposit $5,000 into this savings account. Okay. And the bank says, like, if you deposit this money with us, we're going to give you 2% interest, 2% annual interest. Okay. Annual means year. Okay. So every year they're going to give you 2% of that 5,000 every year. Okay. 2% of the 5,000, 2% of the 5,000. So after so many years, you're going to be able to see how much money you have earned, right? So when you've got, let's see, so let's say you leave it in there for 4 years, right? So 4 years. And we're going to see just how much interest, just how much money is the bank going to pay you, right? Just literally just for sticking your money in their bank and letting it sit there, okay? Assuming you haven't withdrawn or anything like that, or added any more money, things like that. So what we're going to do is we want to see how much interest we got, So that would be our I, that's what we're solving for, right? So IPERT, right? Our principal was what we deposited, so that's $5,000. So we do 5,000 times 2% annual interest. 2% as a decimal is 0.02. I'm running out of room. I'm going to move this down. Sorry. So our interest is 5,000 times 0.02 times, so that's our PRT, is how many lengths of time have we left it there. Now in this case, this is annual interest, okay? So it's not monthly, it's only annual, so it's once a year. So our time frame, or our length of time that we're talking about, is by year. Okay, if this were monthly, I would need to do this 4 times 12. Okay, but we're doing annual, we're doing yearly, right? So we have 5,000 times 0.02 times 4. Okay, so all I'm going to do with this is I'm just going to put it in my calculator. I don't know if you can use calculators or not, but in 7th grade, 5,000 times, I guess it depends on your teacher, huh? Times 0.02 times 4, and what we get is we get 400. So your money has earned you $400 in interest over 4 years. So every year the bank is just paying you $100 to keep your money there. Not a bad deal, right? There's better interest probably, right? You really want compounding interest. You don't want simple interest. You want compounding interest, because compounding interest is where, so the first year you'd earn your interest on $5,000, and let's say, right, $100 you get. The next year, they're going to calculate your interest on $5,100. So it's going to be a little bit more. And then 5,000, I don't know, whatever 2% of $5,100 is, right? So it would be getting bigger and bigger and bigger because it's based off of your balance every year. So that's compound interest, okay? So that's what you really want to get, is compounding interest. But simple interest, this is all it is. So if you can just remember IPERT, and you've got that decimal and the number, the length of time, however it is, right? Ooh, that's a great question, Alina. Is that Alina? How would you tell if you need to find the P in a word problem for this? So with these, what you would do is, if you were told something like, there's actually, there was a problem that I just saw. Okay. Well, so ultimately, really, when you're dealing with a formula, you plug in what you know and solve for what you don't know. So if you were being asked to figure out, like, okay, let's say I earned $400 in interest over 4 years at a 2% rate, right? Then if I don't know what my principal is, right, that's what I'm trying to figure out. So that's why you want to write down the information, right? And you say, okay, so if you see like starting balance or something, they're talking about the principal, right? So this is the P. The 2%, as soon as you see the 2%, that's your rate. Okay, don't get tripped up with the P as the percent. R is the percent, that's the rate. Okay, and then the 4 years is the time. And then the interest is the interest. So again, plug in what you know and solve for what you don't know. Okay. All right. Yeah, principal has a $ sign and interest has a % sign. That's a good idea. Yeah. That is definitely something that would help remember it too, right? Okay, and most of the time the interest rates are going to be per year, okay? Okay, good, Olivia. It's ghostal. It's not always 0.02. It's just 0.02 because this was 2%. So if it were 4%, it would be 0.04. If it was 10%, it would be 0.1, right? You just do the 10%, or you do the percentage divided by 100, or move the decimal over 2 spots, and that's going to give you your decimal. Nathan, yes, I do science as well. Chemistry is probably the best thing to do in this setup and in this kind of area. But yeah, put it away. Let's see. Okay. Max, we just did a bunch on quadratics. So if you go over to YouTube, you can rewind and you can watch what we just did on quadratic equations. But we went through, I'll show you the boards. But we went through solving a quadratic equation by factoring, and we did did factoring, and we did the quadratic formula. Okay. I know you guys want logarithms, but we don't really get into them on this one. It's a little beyond what we do here. Okay. So systems of equations. Thank you for reminding me. Okay. Oh, better vicuna. I do love completing the square. I'll do completing the square if I have time. Okay. All right. So systems of equations. Systems of equations you asked for by substitution, I believe. Okay. So let me pull up some good example problems. Systems of equations. Okay, let's see. Okay, so system of equations by substitution. Okay, when you're solving a system of equations, so the system of equations is where you've actually got more than one equation that is working in a situation, and you're usually trying to see, you're either doing like a piecewise function, or you're doing the like finding the intersection. Where do they break even, or something like that. So systems of equations, there are 3 main ways to solve them. One is by graphing. It's not great. It's not very reliable, but you can at least see what's going on. And you can kind of get a good idea of where your answer might be. The other way is by substitution, where you're substituting one equation into the other equation. Or elimination. Elimination is my favorite. It's so much easier. But let's do substitution. Let's start with substitution, right? So substitution, so if we've got 3x minus 2y equals 6, and then I've got x equals negative y minus 8. Okay, make those bright so you can see them. Okay. So one reason why I may not use elimination on this one is because right now they're not in the same setup, right? So I've got one that's like in a standard form, right? Standard form of a linear equation, 3x minus 2y equals 6. This one is in like x equals negative y minus 8. Like they're not in the same thing. But here we go. What I can do is, a system of equations is where both of these are true. So you're trying to find a value that works for this x and y and this x and y. Okay? So if I were to just add these together, nothing would cancel out. It wouldn't really help me anywhere. Because what I want to do, so if this x is the same as this x, right? I can substitute. right? If I'm trying to solve this and find where this x value is the same as this x value, then what I can do is I can take this whole part and substitute it in for that x. Because if 3x minus 2y equals 6 and x equals negative y minus 8, then 3 times negative y minus 8 minus 2y equals 6. Okay. So we've got this, and now I'm just going to solve for y. Okay, because I can't really solve an equation when there's two variables going on. But now, since I've used this substitution, now I'm only dealing with y. So I can get a value for y, right? I'm going to distribute the 3. So I have negative 3y minus 24 minus 2y equals 6. So now I combine my like terms. I'm going to simplify on this side before I start really solving it. Okay, so I get negative 3y minus 2y is negative 5y minus 24 equals 6. I add 24, add 24. So now these have canceled out. This becomes 30. Negative 5y equals 30. I know I'm going pretty quickly, right? Dividing both sides by negative 5, and I get y equals negative 6. So that's my first part, right? So what this has just told me is that when this x is the same as this x, y is negative 6. So now we got to figure out, okay, well, when y is negative 6, what is the x value? Okay, I can just plug it back in. I can plug it back in really to either one of these. Okay, so I can plug it back in. Let's just go with this easier one, right? X equals negative y minus 8. So I'm going to, here's my original equation. X equals negative y minus 8. So I'm going to substitute again this negative 6 in for this y. So I have x equals negative 6 minus 8. A negative negative is a positive. So x equals 6 minus 8. 6 minus 8 is x equals negative 2. So the value, or the point, the coordinate point, where these two lines will cross on a graph is negative 2, negative 6. Because x is negative 2 and y is negative 6. Okay? Yeah, I know a bunch of you got that before I was even done. All right, so let's look at solving one with elimination. Okay? So like I said, this one I wouldn't do with elimination. Okay. So let's look at a different one. Let's see. I don't want to do one that's like super easy. Ooh, let's do this one. Okay. So when you're solving these systems, the things that you would look for is with substitution, if one of them is already solved for one of the variables, just use substitution. It's easy. But if they're both already in the same format, like the same like standard form, right? Try elimination. So elimination, let's see, we have x plus 4y equals 2. And we have 2x plus 5y equals negative 2. So here we go. So we've got these two equations. Now they're in the same form, right? They're both in that standard form. So I think, oh, I could do elimination. But elimination is where you add or subtract them together in a way so one of the variables disappears, right? Because if this x is the same as this x and this y is the same as this y, it's just like combining like terms, okay? So what I'm going to do is I'm going to multiply this top one by a -2. And the reason I'm doing that is because if I add -2x plus 2x, that x is gone. All right, so I'm going to multiply everything, both sides, times -2. Okay. All right, so that becomes -2x minus 8y equals -4. And now when I add those together, -2x plus 2x, canceled. -8y plus 5y, that's -3y. -4 plus -2 is -6. So now look at how much simpler that is, right? So now you can just do divided by -3, divided by -3, and you get y equals 2. Okay, so I know that when this x equals this x, both of these y's are going to equal 2. So now we've got to figure out what is the x value when y is 2. So we substitute. And I'm just going to substitute it into the top one, because why not? So I'm going to do x plus 4 times 2 equals 2, which means x plus 8 equals 2. I subtract 8 from both sides, and I get canceled out. -6 is what that becomes. So x equals -6. So the point where these both cross, right, is -6, 2. There we go. Okay. Is that Tanini? Tanini, I just did an equation with the quadratic formula just a few minutes ago. So if you go over to YouTube, you can rewind the feed and you can check it out because I did just do that, okay? Should be 3 plus, not 3 minus. I'm not sure where the 3 plus and 3 minus is because this is still, so it'd be -3, -3, -8y plus 5, that's -3y. No. Okay. All right, so. All right, so guys, I know a lot of you are asking, completing the square. I will absolutely do completing the square now. Okay, but I know a lot of you are asking questions. If you, you know what? I know you've been asking for factoring the sum and difference of cubes. That's one of those things where you really just need to know and recognize what it is. You need to recognize it as a difference of cubes. That's all I can really say about that, is that you just need to memorize and be able to recognize when it's a sum or difference of cubes. I'm sorry, I can't really help you much more than that. Okay, let's see. All right, so completing the square, we will do that. Completing the square, I've got that written down. But also remember, if you do have a question that hasn't been answered, or pop it into the chat, and there's a lot of really helpful people that you guys can get some help from. Okay. All right, so completing the square. All right, completing the square is a way of solving a quadratic equation. So let's walk through solving a quadratic equation just by doing the square roots first, okay? So if I have, we're gonna start out real simple. If I have x squared equals 64. Okay, now I know I said it always needs to equal 0, but that's if you're using quadratic formula or factoring, okay? If we're completing the square or doing the square root formula, you don't actually need it to equal 0. It doesn't have to, okay? So with this, x squared equals 64. I can just take the square root of both sides, and I get that x equals plus or minus 8. Okay? So it's either positive 8 or negative 8. Either one of those squared makes 64. Okay? So if I had something like x plus 3 squared equals 16, right? I could still take the square root of both sides, right? Because this is a perfect square, okay? And this one's just a perfect square, but yeah, we'll get to that. Okay, so the square root of x plus 3 squared just becomes x plus 3. Square root of 16 becomes plus or minus 4. Okay, so then you would subtract 3. So then x is either going to be negative 3 plus 4, or x is going to be negative 3 minus 4. So negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. So those are my two solutions, are 1 or negative 7. I know I'm getting kind of scrunched in there. Now, I made these really easy because I made these nice, clean square roots, right? They don't have to be. Okay, if I'm solving by using that square root of both sides, that doesn't have to be a nice, clean square. It can be an ugly, it can be a prime number, it can be whatever it needs to be. It can be a negative, it can be whatever it needs to be. Okay, so we are going to, so if I've got a perfect square on this side, it's really nice to be able to just square root both sides and move on. But you don't always get a nice, neat, perfect square. Okay? But what you can do is you can do something called completing the square. Now what this comes from is from actually completing a square. Okay, so if I'm thinking about something like x plus 3 squared, right? So x plus 3 squared is going to be x plus 3 times x plus 3. Right? X plus 3 times x plus 3. I'm going to actually set this up. I'm going to do the little box method that a lot of people do for factoring. Okay. So I've got x plus 3 times x plus 3. Okay, now since they're the same on both sides, this is going to be an actual square, right? Okay, so x times x is x squared. 3 times x is 3x. 3 times x is 3x. And then 3 times 3 is 9. Okay? So what this would end up being is x squared plus 6x plus 9. Okay? I know a lot of you are out there thinking like, yes, 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 we get it. We understand how to multiply these together. But there's a reason I'm going into this in such detail to prepare you for completing the square. It's because this is the square we are completing. Okay? When you learn completing the square, it's because you are actually completing a square. You are figuring out what goes in this little corner here to make this a perfect square. So let's take a look at an example, right? So if I have x squared minus 8x plus 3, we'll say it equals 0, okay? All right, so when we look at this, x squared is a good square, okay? Now this x squared minus 8x, when this coefficient here, this b, okay, when it is an even number, you can complete the square. Okay, now I know you can complete it. You can complete the square when there's a number here. You can complete the square when this is not. I always tell my students that if this is not an even number and this is not 1, just do quadratic formula, see if you can factor it. It's not really worth the time to complete the square if it doesn't meet these criteria, okay? It's just such a headache. It's such a headache to do this. So why not do it where it's really fun? Because it is really fun to do it. Okay, so it meets all the criteria, right? This is a 1, this is an even number. So what I look at is I say, okay, half of -8 is -4. Half of -8 is -4. So 1/2 of B, all right, 1/2 of B is -4. So if I were to go and make this a square, that would mean that it would be x minus 4 squared. The reason for that is that x minus 4 squared I know is going to give me that -8x. If I think back to foiling, right, looking up here, right, when I had +3 and +3, they added together to make that 6. So half of 6 is what my two like binomials would be, right, or my other digit in there. So that's where this is coming from, is that half of -8 is -4. Now I've got over here, I've got +3. So let's see. So if I had x minus 4, okay, I'm going to go back to my square. And I have x minus 4. Okay, so we do this and we do this. So here, that's way off, sorry. Trying to keep it a little bit consistent at least. So there. And there we go. Okay, so this is going to be x squared. This would be minus 4x. This would be minus 4x. Now, what value completes the square? What value goes in here to complete the square? Because right now I just know x squared and minus 8x. Okay. I just know x squared and minus 8x. So what value needs to go here to actually like complete the square? $16. So if this were 16, that would complete the square. All right, it's not going to be -16 because it's -4 times -4. So positive 16 is the value that's needed to complete the square. So if this were to equal x squared minus 8x plus 16, then I could move it to x minus 4 squared, right? But it doesn't add 16. It's not plus 16. It's plus 3. But what I can do is I can just kind of make it 16, right? Now, I can't just change it to 16, right? I have to use my algebraic knowledge. What I'm going to do is, in order to complete the square, I'm going to add 13 to that 3. Well, what I do on one side, I got to do it on the other. So I've got to add 13 over here too. So now I have x squared minus 8x plus 16, which is a perfect square, equals 13. This opens up a whole new way of solving this, right? So now I've got x squared minus 8x plus 16. So now I can rewrite that as x minus 4 squared equals 13. And now I can just take the square root of both sides to solve. I have x minus 4 equals, yeah, it's 13, a prime number, whatever, it's fine. It'll just stay as a radical. That's totally fine. Equals plus or minus 13. And now I add 4 to both sides. So my x values are 4 plus or minus square root 13. So that's my solution. Could I have gotten this with a quadratic formula? Yes. But this is more fun. I like completing the square. I really do. I really like that. So you do the b over 2 squared to figure out what this is going to be. Okay, a lot of teachers, what they'll do is they'll have you start by subtracting, they would have you start by subtracting 3 from both sides first, right? You want it to just be that equals something. You can do it either way. As long as this ends up being plus 16, you're good. So you can do the half b squared and then just add that to both sides if it's just x squared minus 8x. That would work fine. Okay. Okay. We don't do any logs, but if you have, I don't really get into logs here, but if you have a specific question about them, you can, so natural logs also, so you can put them into the chat and I'm sure somebody will be able to help you out with that. We have a good community in here.
Gia is our #1 gifter, and she just asked for long division of polynomials.
Ooh, Gia, #1 gifter. Long division of polynomials. Let's get into it. I love long division of polynomials.
I know. It seemed like it was a natural fit.
Okay. So long division of polynomials just goes along. Oh. Need to have some cleanup duty over here.
Nemo?
Yeah.
Oh no. Or was it me?
Gross.
Can you do the...
Oh, yeah. Hold on, guys. I gotta do the little puzzle piece. Oh, no. Okay. Oh, go green. Yeah. A little tidbit about me. I am a big old sucker for souvenir cups. And so we have a ridiculous number of souvenir cups. This was from, we went to watch some of my former students play baseball at MSU. So it was a fun memory.
That was the high school...
Oh, was that the state championships?
Yeah.
Oh yeah, that was when they were still, well, I still have a couple of students, whatever. But yeah, go green, go blue. I didn't go to school in Michigan. Okay. Combinatorics, woof, no. Okay. All right, so long division of polynomials. Oosh poosh, I did some factoring earlier in the video, so go over to YouTube and you can rewind it, and we talked about factoring a fair amount right at the beginning. Oh, no, I'm not an MSU math PhD. Nope, not at all. Just live in Michigan. Love Michigan, but, okay. So long division of polynomials. So long division of polynomials follows the same general algorithm as just long division of numbers that you learned, probably that you learned in like elementary school. So, a couple of things is to do long division. Hold on, I'm gonna pull up a sample question, hold on. There we go, okay. So we'll do, let's do 6x squared plus 7x minus 20 divided by 2x plus 5. Okay. All right. So this is going to go outside the house. This is going to go inside the house. Okay, so we set it up so we have 2x plus 5 out here. And then in the little house, we have 6x squared plus 7x minus 20. Okay. So like long division of numbers, right? We're going to look at, okay, we're going to kind of look at one digit at a time, or maybe 2 digits at a time, right? Sometimes you look at 1, 2, depending on what you're dividing by. And you kind of go, okay, so this divided by this thing that's outside is this, all right? You look at like how many times can this go into here without overflowing, right? Or overfilling. So in this case, what you actually do is you just focus on the first term out here. So I'm just looking at 2x, okay? This plus 5 is just along for the ride. It's just tailing along, or tagging along, it's fine. Okay, what we're really looking at is 2x and these numbers. Okay, so this term and this term is what we're really looking at. And we're thinking, okay, 6x squared divided by 2x. Or you could think of it as, what do I need to multiply 2x by to get 6x squared? Well, I know I need to multiply by 3 to get the 6. Then I need to multiply by another x to get the x squared. So 2x times 3x is going to give me 6x squared. Okay. Notice I'm starting it over here. That's just kind of like setting it over the right, like sort of arrangement, kind of like place value. I know it's not place value. Don't come at me. But like it's sort of like keeping it organized, right? Now what I'm going to do is I'm going to take that 3x. I'm going to multiply it all the way through this. So I'm going to multiply it by the 2x, and that becomes 6x squared, which is great. That's exactly what we wanted. And then this 5, it's going to multiply by that 5 also. Again, it's just kind of along for the ride, right? So we do plus 15x. Okay. So now, just like long division of numbers, we subtract. 6x squared minus 6x squared, canceled. 7x minus 15x is negative 8x. Okay. And now I bring down the minus 20. Okay. Again, I'm just going to look at the first term and the first term. So 2x times negative 4 will give me negative 8x. So I do minus 4. Do I really pay attention to the 5? No, it's just along for the ride. But now I do negative 4 times 2x, which is negative 8x, which is exactly what I wanted, right? And then negative 4 times 5 is negative 20. So when I subtract these, everything cancels out and I have no remainder. So 6x squared plus 7x minus 20 divided by 2x plus 5 equals 3x minus 4. That's long division of polynomials. Arwen, how'd you do on your test over this? Hopefully you did well. All right. It is about that time. It's not that hard. It's not that hard. And if you get to down here and you do have a remainder, okay, there's no. Oh, yeah. So, yeah, there technically should have been parentheses around there. Sure. Yeah. But if you're doing a division problem, you're going to realize that that's what it is. So with the remainder, so if I had a remainder of like, let's just pretend, okay, we're just pretending, if this were a remainder of 3, okay, that remainder would go above this part, right? It would be plus 3 over 2x plus 5. I think that's the divisor. Okay, so that's what the remainder would be, is it would just be whatever the remainder is over the original thing that you're dividing by. That's it. Connor, we go live every Thursday at 8 o'clock. Well, I guess 8 o'clock Eastern. But yeah, there we go. Oh, synthetic division. Oh, I can do synthetic division. Dang it. I can do synthetic. Okay, Gia, I'll do synthetic division. Because that one is actually really pretty straightforward too. So let's do a synthetic division. Okay. This is my last board, guys. With all my sloppy notes on there. Okay. So synthetic division is where you're really just paying attention to the coefficients, okay? So I'm gonna go off live after I do this one last problem. So if we've got, I'll put parentheses around it, 2x cubed minus 5x, oh wait, no, wait, that one has a remainder. I don't wanna deal with the remainder right now. Let's do x cubed minus 2x squared minus 5x plus 6 divided by x minus 3. Okay? All right. So with synthetic division, so this is where we're really just kind of using a very shorthand way of doing this, but it's still going to be like bringing it down, adding them together, all this kind of stuff. Okay? So you draw this little L shape here. It's sort of like you take the division house and like flip it upside down. So inside is going to be the coefficients from here, right? So I'm going to double check that I have 3, 2, 1, 0 for the exponents. If I were missing an x squared, I would put in 0 for the coefficient. But we're just going to do this one. So my first coefficient is 1. Then I have -2. Then I have -5 and 6. Okay. So I list my coefficients there of this part. Out here, I'm only going to use the opposite of this, which is +3. Okay, so I flip the sign on here and I use 3. Okay. What I'm going to do is I'm going to do, first step is going to be just to bring down that first coefficient. So I just drop this down as a 1. Okay. So now what I do is I'm just going to do multiply and add. Yes, I would flip it no matter what. Even if it was already, it's not that this has to be positive, it's that it has to be the opposite of this. Because remember in long division, we're subtracting, so we have to flip that sign, however it is, okay? So now I do 3 times 1 and put it up here. Okay? And then I add. 3. So I do 3 times 1 is 3. Add those together, which gives me 1 again. 3 times 1 is 3. Add them together, -2. 3 times -2 is -6. When I add them together, it's 0. This last spot is always going to be your remainder. And in this case, I don't have a remainder, which is very nice. Okay. These are the coefficients for my solution. These are the coefficients for my answer. I'm going to start at 1 less degree than up here. Okay, so this is not going to start at x cubed. This is going to start at x squared. So my solution is x squared plus 1x minus 2. That's my solution. Okay, so I just bring it down. 3 times 1 is 3. Add. 3 times 1 is 3. Add. 3 times -2 is -6. Add. I get 0. Okay. Yeah, synthetic division is not super complicated, but it can get confusing if you kind of lose track of what you're doing. All right, guys. So, good, Gia. I'm glad that helped out. Have a great night, everybody. I will be back next week. Same time, same place. 8 o'clock Eastern. Yeah. All right. Good night.